Hello there, my name is Lawnardo and I will be the presenter of the group. We are a group of 3 people with my 2 other teammates, Rosa and Tiffany. We put a lot of time and effort doing this hackathon and I hope that you will enjoy this presentation. This hackathon aims to predict the GDP growth of recent years or next year for China and India by building a regression model. The objective and definition of GDP were taken from the hackathon PDF file. So GDP stands for Gross Domestic Product, and it is the most widely used measure of a region's economic capability. And then, how to predict GDP growth. For starters, we will research and obtain factors contributing to GDP growth, and then we will build a regression model using the variables to predict the following year's values. Looks simple, right? I mean, is it that simple? Well, let's take a look at the next slides. First of all, how to choose the independent variables, or the better question is, what factors contribute to GDP growth? So we did basic research on the internet like what factors contribute to GDP growth. Then after group discussion and agreements, we decided what factors we should find on the internet. But then, it's not that simple. Some problems we encountered are that not all the factors are available on the online database. Then also comes incomplete set of database input. Say some factors have missing year data points or has small amounts of data points. Then, sadly, after attempts on making the model, factors that we thought would be important for GDP growth are tragically unimportant. These are some of the independent variables that we believe are drivers to a country's GDP growth. We believe that there are still many more variables that can be attributed to a country's GDP growth, but these are the variables with sufficient data around it. A country's GDP should increase when the population increases, the labor force participation rate increases, the unemployment force rate decreases, the inflation rate of that country decreases. This is because inflation will increase the cost of production factors leading to lack of demand and a decline in production. Then, the net export of a country increases based on the GDP equation expenditure approach. As the mortality rate of a country decreases, the urban population of a country increases. As the value added by agriculture, forestry, and fishing increases as there are more value generated for production factors. Then, as the government final consumption expenditure of a country increases based on the GDP equation. And finally, the household and non-profit institutions serving households' final consumption expenditure of a country increases based on the GDP equation. The GDP equation expenditure approach will be shown in the supplementary article. This slide shows the regression model we ran for China using around 10 variables, and it shows that the regression produces a relatively large R-squared of 0.891 shown in the red box. So 89.1% of variance in the dependent variable that can be explained by the independent variables. The probability of the F stat of 4.02 times 10 to the power of minus 6 shown in the blue box being lower than the significance level of 0.05 means that there is enough evidence to conclude that the overall regression model fits the data. The independent variables used to construct the model can be seen in the purple box. However, the p-value of each independent variables shown in the green box are insignificant for some, and some of the independent variables coefficients have the wrong signs shown in the orange box. One explanation is that there exists multicollinearity between the independent variables, or some of the independent variables are highly correlated. To improve the model, we try to eliminate variables that do not carry useful information. From the 10 independent variables from the previous slide, we narrowed it down to 5 independent variables based on their effects on the GDP according to the GDP equation and their role as the economic growth drivers. Net export, government expenditure, and consumption are some of the key components of the GDP equation. Moreover, we believe that labor force participation rate and inflation rate strongly affects the economic growth of a country. This regression produces a relatively lower R-squared shown in the red box, so 67.8% of variance in the dependent variable that can be explained by the 5 independent variables shown in the purple box. The probability of the f-stat is of 0.0002 shown in the blue box being lower than the significance level means that there's enough evidence to conclude that the overall regression model fits the data. But then, however, the p-value of each independent variable shown in the green box are still insignificant. As stated just now, there exists multicollinearity between the independent variables. So to improve the model, we tried to change different combinations of the independent variables that we believe carry the most useful information. The regression produces a relatively lower R-squared of 0.81 shown in the red box, which can be explained by the 4 independent variables shown in the purple box. The probability of the f-stat is much lower shown in the blue box, being lower than the significance level. And the p-value of each independent variables shown in the green box are insignificant, as they are lower than the significance level of 0.1. However, some of the independent variables coefficients still have the wrong signs shown in the orange box. Using the critical t of 1.72 and the overall model standard error of 1.06, we get the lower 90% and upper 90% bounds of the prediction of 3.38 and 7.04 respectively. Since the actual GDP growth in 2017 was 6.75%, it's still within the 90% prediction interval, and thus the model is valid. The final regression model to predict China's GDP growth is constructed using these 4 independent variables. We believe that as the population growth increases, the GDP growth of the country should increase as well as the population consumption increases, and consumption is a key component of GDP. The increase in the labor force participation rate should increase the GDP growth of a country, as it also drives the consumption component of the expenditure representation of GDP. The increase in the net export of goods and services should increase the GDP growth of a country, as net export is one of the key components of expenditure representation of GDP. The increase in mortality rate under 5 should decrease the GDP growth, as it decreases the consumption component of the expenditure representation of GDP. However, all of the independent variables we used to construct the model have the wrong coefficient signs, except for the net export variable. It seems that there still exists multicollinearity among the variables, that is, population growth and mortality rate being highly correlated. We tried removing one of the variables, but it still doesn't improve the overall model fit significantly. The above relationships between the independent variables and GDP growth are only what we assume and expect, and we could be wrong too, especially as we're relating GDP growth with incomplete collection of independent variables. There's certainly more to learn about the complex relationship of GDP growth with its constituting independent variables. This final model seems to be the best model we can come up with given the limitations of incomplete data on some of the independent variables that we believe are drivers to the GDP growth. Now, going to India. Just like China, we ran a regression uh, with the 10 initial variables from the year 1991 to 2016 as our first effort in trying to account for reasons which may explain India's GDP growth. These variables are shown through the purple box. As shown in the red box, an R-squared value of 0.5 means that just over 50% of variance in the dependent variable can be explained by the independent variable. Although an R-squared value of more than 0.5 in a regression model is usually concluded as valid in the field of social sciences, other results, however, shows that the model is still deemed to be insignificant. First of all, an f-stat value must be below 0.05 in order to be concluded as significant. Thus, as shown in the blue box, the relatively high f-stat value we gained meant that the evidence we used was not strong enough to conclude that the overall regression fits the data. Next, the p-value as well as coefficient value is displayed in the green and yellow box respectively. Ideally, the coefficient values must all have a positive sign, representing a strong correlation between the variables. Furthermore, we use the benchmark of a p-value of 0.1 or lower in order for each variable to be considered significant. As shown, however, both these cases were not fulfilled. In fact, not one variable exhibits a significant p-value. So overall, results from this initial regression model is not significant. Hence, the ideal combination between independent variables must be found in order to best explain the reason for India's GDP growth. Well, again, just like before, we attempted to just use independent variables which we think plays the biggest roles in the official formula of GDP, as seen through the expenditure approach. This attempt marks our second shot in trying to explain the factors which affect GDP growth in India. Well, here, our variables are narrowed down to 5, which is displayed in the purple box. Compared to our initial try, although the R-squared value decreases, indicating that less variance in the dependent variable can be explained by the independent variables chosen. The f-stat value decreased, thus signifying that there is more evidence to conclude that the regression model fits the data. Moreover, 2 of 6 elements show a p-value of less than 0.1, thus signifying that there is an improvement in the degree of significance in the independent variables. Although there is definitely an improvement in results implying more significance in this regression model in contrast to the first one, but still, the change is ever so slight that this model still could not be implied as one that is significant. A more ideal combination of independent variables which would best explain the country's GDP growth is yet to be discovered. Next, because both India and China are of similar size in terms of population, hence we tried using the variables which work best to explain China's GDP growth in an attempt to explain India's GDP growth. The left regression model uses variables which are exactly the same to that of China's final variable, which is population growth, labor, net export, and mortality. When applied to India, however, the model yields a relatively low R-squared value as seen in the red box, and a relatively high f-stat value as seen in the blue box. Moreover, none of the independent variables exhibits a significant p-test value, and its coefficient values still have different signs. Overall, this shows that the independent variables do not have a strong correlation with each other, and furthermore, cannot be used to explain the dependent variable of this model, which is India's GDP growth. After that, we examine that out of the 4 variables, one which China and India differ most is in its net export. China, being a powerful world exporter, has data which shows this power through having high net export numbers. On the other hand, India is a country which imports more than it exports, eventually creating net export values which are of negative value. Due to this difference, we ran a regression model which did not take into account the net export factor, and this is shown through the model on the right. Although f-stat and p-test values are lower than the left model, and thus shows more significance, the model still failed to conclude itself as significant overall. Thus, even using these three variables, the GDP growth of India is still not accounted for. From our previous failed attempts, we tried making various other combinations using the 10 independent variables data we have. Two examples could be seen here where the left model we use independent variables we think most relate to finance, as well as in the right model where we use the independent variables which have similar graphical shape. Through our attempts, however, we could not seem to find a model which is of significance and could be used to explain the GDP growth of India. Thus, to try and solve this problem, we added 6 more possible independent variables, especially for India. We chose this because, due to India's abundant population size, transportation methods like air transport, trains, and the government's public-private partnerships investments, in transport we must play a huge role in India's economy. This is especially true due to the country's status as a developing country, which put them at a position where transportation infrastructure is a must to connect citizens from around the country together. Electricity is also of importance to the world and especially to India as the country continues to develop. Electricity sources becomes more widespread in the country and governments start to invest in clean energy and electricity options. With the addition of the 6 new variables and through more attempts, we finally came up with a regression output which we think could best account for India's GDP growth. The independent variables we finally chose are unemployment rate, government expenditure, investments in energy projects, and household expenditure as shown in the purple box. The regression produces an R-squared value of 0.4, which although is not higher than or equal to 0.5, which is the value most social science studies would use as benchmark to imply an acceptable regression model, in contrast to the other attempts through the many different combinations of independent variables to explain India's GDP growth. And relatively, the value is relatively high. Next, the f-stat value of 0.0237 and shown in blue is lower than the significance level of 0.1. This implies that there is enough evidence to conclude that overall regression model fits the data. The p-value of each independent variable shown in the green box are insignificant as they are lower than the significance level of 0.1. However, just like that of China, some coefficients of the independent variables show negative signs as shown in the orange box. This may be because multicollinearity still exists between the independent variables, or some independent variables are highly correlated. Though definitely far from perfect, this regression model along with the combination of independent variables is what we think best explains the GDP growth of India. That being said, although the regression model is one which we think is most significant, the prediction of GDP growth for India in 2017 was very different with India's actual GDP growth. Thus, although in theory the regression model we came up with is the best we could come up with, this model still turned out to yield an inaccurate prediction of reality. This is supposed to be supported by the fact that the actual GDP growth in 2017 was 7.16% and it doesn't fall within the 95% prediction with the interval with the predicted value of 2.6 and then with lower and upper bounds of minus 0.29 and 5.49 respectively. This is generated from critical t value of 1.72, standard error of 1.68, and predicted value of 2.6. The final regression model to predict India's GDP growth is constructed through these four independent variables, following the GDP formula from the expenditure approach, which is consumption plus investment plus government spending plus net export. Hence, we believe it is true that the higher general government final consumption expenditure, investment in energy projects, and household and NPISH final consumption expenditure in turn results in higher GDP growth. On the other hand, however, we believe that the higher the unemployment rate throughout the years, then GDP growth should be hindered as the economy is not using its maximum potential. Nevertheless, this assumption we hold may be the reason why even in the final regression model, opposite coefficient signs still exist. The wrong or negative coefficient sign, however, is obtained by the general government final consumption expenditure. Hence, the conclusions surrounding the relationship between the independent variables and GDP growth, which we propose, are solely assumptions, which could be wrong, especially due to the constraints of data and time available for us. Certainly, there are regression models which could explain India's GDP growth better than ours. However, with what was available to us, the model we proposed was the best one we could come up with. Well, all in all, we conclude that these are the independent variables we use to decide the GDP growth of both China and India. There are limitations and unknowns that may need to be resolved for a better modeling. The rest of the information will be covered in the supplementary article. Thank you for your attention in this presentation.